everyone, and thanks for watching this video. In this video, I will show you some new features in the EvoMass version 0.3.0. So there will be three major parts in this video. Showing you the first thing is about how to connect two or more components in the organization. And the second one is how, and the second and third one is new features in the additive and the subtractive generated component. So let's start from the first one, how you can now to connect two components in the organization. So let's set an example. We may just generate two building meshing. Respectively use the additive and the subtractive components. So let's generate the two buildings first. And we also want to make these two buildings separate a little bit. And now, let's say you have the two generated components you want to, or two building meshing, and you want to organize the two building meshing all together in the one organization process. In the previous version, you cannot do that, but in the new EvoMass, you can do so. And not only two components, you can also have three or four, but you need to remember that when there are too many components, it means that there will be a large number of parameters. So it will cause severe difficulty for the organization algorithm to search for the optimal solution. So just keep in mind this, and if you are using maybe more than two components, you need to increase your iteration of the organization. So in this case, let's say we are trying to search for let's say we divide the total gross area of the two building meshing as our fitness. So let's say we're using the cube. First, we extract the area, gross floor area from these two components and do the addition operation. So we get the combined gross floor areas of the two generated components. So now the second step is that we can connect our evolutionary algorithm SSIEA component simultaneously with these two generated components. So first we connect the first one, and then we press the shift button, and then to connect the second one. And also we connect our fitness to the combined gross area. So after that, we can duplicate the SSIEA component, and we can see that in this viewer, you can find that there have a two component named here. In the previous function, there will be one component, and so now you can see the component 0 and also the component 1. And also you can use the output to set the direction for organization. And also in this version of the EvoMass, the backup function is also improved. So for the moment, the backup will only just say the in-progress data of the organization. This function also restore the whole GH file as well as the generative setup of these two components in the backup folder. So if we want to use this backup function, you need to first save the current GH file in your computer. So let's say that we save this in one of our folder, and let's say the test, and we delete the whole backup folder first. We already saved the file, and now we can see here is the new created the GH file. So for a moment, let's see, to do a very fast trial run of the organization. Let's say we can increase the number of the generation here, maybe just like a 4, right? But when you're reusing EvoMass for organization, just keep in mind that at least make the iteration larger than 1,000. So let's start the organization. So for the moment, you can see that when the organization started, you will find that the 2 generated component or the 2 building message will be changed simultaneously because the organization algorithm can control the 2 components altogether. So it means that when you really run the performance-driven organization, you can find how these 2 building messages can be incorporated to create the more progressive performance improvement using the organization. And also you can see here already have the backup file. So in the backup file, you can see that the GH backup is the GH file when you're running the organization, and here the 2 setup file is the parameter setup for these 2 generated components, and this vector 001 or the 000 is the in progress organization data. So you can use this data to recreate the whole organization project when you finish the organization, or when you're running the organization, maybe you have a power failure or your computer accidentally shut down. You can also use this backup file to reload the whole the data already finished in the organization and rerun the organization in another computer or when you restart your computer. So here is already finished the organization, and let's say if we close this one, and let's say also this one, and here when you reopen the whole GH file next time, and you can also be here and also using this to load the project in the backup file. You can select the last one is the one when the organization is finished to reinstate the whole project. So you can see that they can to change the 2 the generated components simultaneously. All right, this is the first part of this video, and now we will go to the second part about the 2 generated components. So we will start with the first additive component, because most users will be more interested in using this component. Let's generate the first design. And the first function I want to talk about is the full high constraint. Because when some user use the additive component for the high-rise building, because some internal vertical constraint, the generated design usually cannot reach the floor level number divided by the user. So let me show you an example. So you can see here have only 29 floor level. Let's generate another one, and to see whether we can find let's say this one a little bit shorter than the previous one. So we will expect that, oh, okay, we only have a 22 floor levels. So actually the designer defined like a 30 floor level. So it means that this at least have an 8 floor level lower than the expected floor level number. So if you enable the full height constraint, you can see that the building will be stretched to the 34 level when you use this function. So in this case, you can use this constraint to always set up to enforce the generated design to reach the maximum floor level you divided. So here is the first function, and let's move back to the 10th floor level, and also using the exercise constraint. And when also the second new function is the field boundary constraint, because when you're using the additive one, let's go to the top perspective, you can see, and actually the boundary is actually a little bit larger than the generated design, and in some cases the designer may want the generated design can always can be aligned to the boundary of the building plot. So you can use the field boundary function to make the generated design to at least in each of the edge of the boundary, at least one mass unit will be touch the boundary. So if you can also disable this, you can see that the building will be more compact together if you do not enable this function. So this function will also allow you to generate the building matrix more separate and more distributed in the whole building floor. It may be more useful for the project like a kindergarten design or something like a small house design. All right, and the third function is about the spacing. In this new EvoMass, you can see that you can set the column spacing in both directions. It means that the building don't necessarily only have using like the qubit or the box the qubit column grid unit, and you can set like a little bit stretch, so you can change the whole shape of the design. And also maybe you already know that in the previous update of the EvoMass, you can set the different the window opening type. So if you are combined with this function, you can see here the window will be a little bit different, because in this function in this direction, the x direction is still the 7.2, so it's a little bit like a rectangle. And but in this function, the building the window, you can see a little bit stretched because you use a large value in the y direction. So let's go back to this one. So you can see in here the window size will be keep the same in both directions, because you're using the same column spacing values. All right, so let's go back to the simple for this, because it can be a little bit fast. And the third set of the new function is about show the boundary and the scaling, because the show the boundary is also asked by some user that, especially when using additive generated component, you don't need how large the boundary of the generated design. So sometimes we will see that because just like the previous function, that you don't know whether the building is started. So maybe you will put your external building here. So in that case, the next design, the generated design, may be will be overlap with your existing building. So it is very important to know the boundary of the generated design. So here you can use the display boundary. You can see how large of the building, the boundary of the generated the generated building meshing. So you can more easier to change the column grid number. You can understand the size of your the size of your column grid system. So it will be easier to make your generated design fit into the context. All right, and the next thing is the scaling factor, because when I developed the EvoMass, it's based on the meter system. So, but when you connect it to some simulation tubes, they will ask you to convert it to like a millimeter unit system. So in the previous when you're using the previous version of the EvoMass, you need to manually scale the whole building meshing for the simulation too. But in this new version, you can use the scaling method here just to very fast to feed the generated design into your expected system. Let's say like a 5 here. So the building will be generated with the scale larger in the ratio of 5. And also you can see the boundary will be also changed. So let's go back to the one. And the last part of for the Untitled component is the new function of the custom boundary and the external volume. In the previous version of the EvoMass, usually you're already familiar with the cutting boundary. Usually you will generate some very jaggy boundary, jaggy edge of the building meshing. So some user complain that this is very unnatural when you're designing a building meshing. So in this new version of the EvoMass, I improved this function and make it more practical to use for the architecture design. So let's draw a boundary here. We can set the boundary. Yes, you can see that the current boundary is too small because when you set the boundary, you need to using here to see how large your actual boundary is. Let's say we can stretch this a little bit larger. All right. Now you can see that whenever you generate the building, they will always within the boundary. And also you can create a little bit more complex boundary here. Let's say delete this one and show the boundary. Let's say we want to a little bit more complex boundary here. And set this as our custom. You can see that all the building will be still within the boundary. And also, if the algorithm cannot find the perfectly matched design, to actually cut the boundary, not like the previous one here will be like a very a jetty or zigzag shape in the generated design. And let's say let's make it a little bit bigger. So you can see that here they will still cut very clear, cut the whole boundary. So you don't need to worry about the very jetty shape of the building. So here will be looks like this. Also the window will be also customized according to this edge, so you don't need to worry about the windows. But of course, it cannot perfect because this is a little bit standard in terms of the generation of the window frame, but it still can generate the windows for you. So let's say we generate another one like this one. So in this new function, you can always generate the building meshing within the boundary. And also, when you're using this function, you can also use the display boundary to see the boundary of your design to check whether this boundaries can be fit into your the condition of your project. All right, so let's also see the custom boundary, and then another new function here is the external volume. This is similar because when you're doing the when you're using the old version of the EvoMass, the external volume is usually can also be like have a zigzag edge because they will always follow the one grid unit. But in this new function, they will just like this one. They will just directly cut the whole. They will just follow whatever the input volume divided by you. But just keep in mind that you don't want for the moment the algorithm cannot accept curvy, no matter for the custom boundary or the external volume for the design generation. So you're always using like a boxy or a more regular shape for these two functions. So let's say we can still create, let's say, this one, and we can draw a line. So we set the external boundary. All right, you can see that the boundary will be no longer like the previous one. They will have a very jagged edge. They will always to perfectly match the boundary we define. But if you see the first floor cannot generate, you can actually make this a little bit lower, so they can make the first floor to be created. Like this. All right, this is basically the all updates for the addictive component. So we will move on to the subtractive one. So let's delete all this thing. Component, and here we draw a new subtractive component here and generate the design. And here we can see that this is the one, and we still have the very similar updates as the addictive one. So like the display the boundary and also the scaling factor. And I forgot to say in the previous one is that the call control distance, when you generate a call, in the previous function is hard-coded in the whole generated design, but in this function you can actually change the control distance. Sometimes it's not very obvious. Let's say 50. No change. But just keep in mind that this function can allow you to change the number of the control distance of this design. All right, so the same thing is here is that about the custom boundary and the external volume. The external volume is very similar to the addictive one, but I will just show you an example of how you can define a custom boundary. All right, so we draw the custom boundary here. But when you use the custom boundary, just it's more wise to disable the generate call function. And let's say we set the boundary. So in this new function, because in the previous one, when you're using the custom boundary, there will actually sometimes we generate very thin volumes in the generated design. So in the subtractive one, I just try to overcome this problem and always keep the vertical subtractor inside the boundary. And also do not generate those very thin volumes in the generated design. And also when you disable the boundary constraint, you can see that you can still go to the, you can see the create the side opening void in the generated design. And for the external function, it's still very similar to the updated one, so I won't show this in here. So I guess this is all the new updates for the EvoMass version 0.3.0. So I hope you enjoy the new version of the EvoMass, and also looking forward to your feedback if you have some other good suggestions. Thank you.